1 is equals to x2 minus x1. And our slope 1 is equal to y2 minus y1 is equals to x2 minus over x2 minus x1. Our M2 will be negative A over R. Okay, now equate M1 and M2. Okay, so M1 equals M2. Let's observe what will be happening. Okay, so M1 is equals to M2. Our M1 here, class, is the slope originally from algebra, which is y2 minus y1, sorry, over x2 minus x1. Okay. And the M2 here, class, is in the graph, which is negative AA over R, which is over M2. So substitute that here, so we can have negative EA over R. Okay. Now, guys, involve the natural logarithm in the slope y2, y1. How can you do this? Since we have the ln k in the y-axis, and we need to have 2 points here, so we will automatically use ln k2 and ln k1 because we have 2 points to consider, the y2 and the y1, right? For the directly proportionality concept. So we have ln k2 in the y-axis and ln k2 and k1. Okay, so y2 will be for ln k2. Oh, substitute sa y2. Or ln k2. Okay. Minus y1, which is also ln k1. Okay, like this. I assume to be that because ln k is our y-axis. Okay, so ln k1 over x2. Remember, our x-axis is 1 over t. Since we have 2 points to consider 1 and 2, we have also 1 over t2 and 1 over t1. And then our x2 will be 1 over t2. And our x1 will be 1 over t1. And substitute that to x2 minus x1. Okay, so 1 over t2 minus 1 over t1 is equal to the activation energy negative over R. So this one. So this is a very complicated equation pa. We need to simplify pa talaga siya. Okay. Using again integral calculus in the numerator here. Because I introduced in my introduction 4 laws of integral. Okay. Apply that here. That subtraction na ta siya. Number 2 law of integral. ln a minus b is equal to ln a over b. Apply that here. Okay. Since I have ln k2 minus ln k1. So I could say ln k2 over k1 in the rule of integral calculus. Okay, that's very clear, right? It's in here, right? Integral calculus law number 2 in here. Okay, now, so let's be patient so that we can derive the exact formulas we are wanted to. Okay, it's gonna be like that. Do not so fast, not take so fast because it will be wrong. So 1 over t2 minus 1 over t1 is equals to negative t8 over r. Guys, again, algebra. As you can notice, we are employing algebra and integral calculus simultaneously in our solution. Okay? Baden integral calculus, baden algebra, baden integral calculus, baden algebra. It's just like that. Okay? So we cross multiply because in a rule of algebra, you have the crisscross multiplication method. You put an x and multiply that situation like this. Okay, like this. Okay, here times here, here times here. Basic in algebra. Okay, so ln k2 over k1 times the universal gas constant. Okay, so r. Okay, times ln k2 over k1, and then negative AA times the whole thing of this temperature's gradient here. Okay, so a negative activation energy times close and open bracket like this. This is the whole thing. We need to employ close and open brackets if we mean the whole thing of a certain, quantity. Okay, so we need to have 1 over T2 minus 1 over T1. So like this. What do you notice here, class? It's already simplified or not? Zone E, take a closer look. This is already simplified or not? What can you say? It's not, because there's still a variable in the other side, and there's also a variable in the other side. So all we have to do is to remove the R in the right side, on the left side, so that it will become ln K2 and K1. Because if we press the ln to a certain number, we'll yield an answer, or we'll yield a number. So we need to remove the R. So if we try to divide the R, this portion, we need also to divide the R at the right side. Okay? So divided by R, okay? Divided by R cancels out like this, okay? Like this, cancels, okay? Now we have ln K2 over K1 is equal to negative AAR times 1 over T2 minus 1 over T1. Okay, bingo. This is our equation number 2 of Arhenius equation. Actually, this is the specific Arhenius equation. The other one is our parent equation. It's not really specific. This is the general equation. Okay, we can never use this because there's still a exponential factor A, and it's very difficult to troubleshoot what's the value of capital A. Okay, something like that. So it's here, right? Now, if the problem will ask you to solve for K2, K1, T2, T1, and then blah, 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 so on for activation energy, then you can solve that one. Okay, by substituting values. Now, to make it easy again, to simplify more. Okay, like that. To simplify that more. That's why also, class, you can find this in the book like this directly. Okay, in book, chemistry book, physical chemistry books, thermodynamics book, they will give you like this automatically. This one. They will just discuss in the introduction how to get it, derive it, something like that. Okay, same story as what I did. Okay, something like that. Okay, then we need to calculate K2 because most of the problems will try to ask what is the rate constant final of this chemical reaction. So that is K2. So solve for K2 in this general specific equation. How can you do that? Okay, like that. Actually, I memorized already, but I need to divide. Okay, because if my memory fails, I can still remember something like that. But in a certain examination, especially time pressure, no need to derive because it take a longer time. You have to memorize talaga siya. Okay, as long as you understand how to derive it. Okay, something like this. Okay, so solve for the value of K2, K and T2. Okay, guys. K2, T2, and activation energy are the usual quantities to be asked in the problem related to chemical kinetics Arhenius theory. How can you solve for temperature final, activation energy, and K2? Since in here, this is still a mixed, a mixed specific equation. Though this is already specific, but there's a mix of variables. Okay, this is the general formula here, somewhere out there, the first one. Okay, now again, employing algebra. Okay, algebra again. Okay, employing algebra and integral calculus also. Okay, so we have this. Okay, going back to this equation. Okay, now, okay, ln ln K2 over K1 is equals to negative AA over R times 1 over T2 minus 1 over T1. Now, guys, I memorized already that the value of K2 is equals to K1 times the exponential of negative AA over RT. That's based on my memory. Okay, and T2 is equals to 1 over T1 minus negative EA ln, okay, K2 over K1 over R. That is the T2. And the activation energy will be equal to, based on my memory lang siya talaga, okay, 1 over T1, something negative A, something like that, and ln K2 minus K1 over R, like this. Okay, that's activation energy. Okay, something like that. Understand? So activation, but we have to prove that one by deriving again. Okay, because maybe you can forget because so many so many quantities. The usual thing you will forget because that's not only one quantity. It will be it will be vanished in our brain cells. Unlike words, words. For example, if we memorize what is the definition of a boiling point, it's easy to recall because all our words, all our statements. But in this manner, guys, quantity, and subscript like this. After 6 months, after 1 year, after 2 years, you will never recall this already. I think so. Except for the very basic, for example, density, mass over volume. Like that. But in this case, so many ln, you could no longer memorize this after 5 months, after 8 months, after 1 year, after 2 years, after 5 years, right? Compared to the definition of the boiling point, definition of the density, formula of the last momentum. It's very easy because there's no such subscript, too much variables. Now here we need to derive something in this purpose only, okay? Though we memorize, my point is, as the time go by, you will forget a little bit for this, okay? Because so many subscribes, so many variables, okay? Like that. So again, we need to compute for EA, okay? Like that. So how can we do this? Charot. Okay? Ganon. So K2. Oh, ganon. What can you notice here, class? K2. Okay. K2. Here. K2. How can you do this? So that you can remove the ln K1. Again, integral calculus. Okay? Exponential to the ln is equal to 1. So put this side, two sides with exponential so that you can have ELN is equals to 1. So wala na siya labad sa ulo. Okay. E raised to the power ln is equals to 1 in integral calculus. So substitute and apply that here in your chemical reaction. So LE ln K2 K1 exponential negative EA R 1 over T2 minus 1 over T1. Okay, exponential both. Okay, observe. Quality of a scientist is to be observant. Observe. Okay. So both have E, right? So the other one to be exponential. The other one is to be cancels out as 1. So 10, 1. Okay, something like that. Okay. What will remain is the K2 over Q1. Okay. Put that or drop that below. Okay. K2 is equal to K1. Now, still exponential, put that in the same manner because there's no ln in that. Okay. So negative AA over R 1 over T2 minus 1 over T1. Okay, guys? Like that, huh? Okay. My gosh. Okay. This one, K2 over K1 is equal to the exponential negative AE over R times, open parenthesis, 1 over T2 minus 1 over T1. Now, guys, notice this. Apply algebra by the crisscross multiplication. Okay, like that. So our K2 now will become automatically as, okay, K2, okay, K1 times exponential negative activation energy over R times 1 over T2 minus 1 over T1. This one. Bingo. This is our formula for K2. So our formula of K2 will be K1 times exponential negative EA over R, close and open parenthesis, 1 over T2 minus 1 over T1. And then the problems have data, substitute that there directly. Okay? And you can solve for K2. Okay? Like that. This is K2. Now, we solve for T2. How can we do that? Okay, T2. Okay. Now, going back to this equation like this. Okay. Okay. Ln K2. We have to get another paper. Okay. Solving for T2. The purpose of this, guys, is to make it direct. Okay? To make it direct so that it can save you time. Oh, I have the formula of T2. Oh, I have the formula of activation energy. Like this. Rather than you will derive pa, or rather than substituting, the tendency here, class, if you try to substitute one by one here, there's still a lot of variables. So sometimes you will be messed up unless you are really a mathematics lover or a genius, a mathematician, or whatever, chuba chuchu. Good in mathematics, then you will never be confused. But for us, average, okay, little above average, like this, we're not really that good enough with mathematics, then we will abide and follow what is really the most simplified one, okay, so that we will not be confused, okay, especially if we don't have a very high mathematical ability, something like that, or mental ability in mathematics. Okay, so T2, okay, what will be our T2? Okay, now going back to the formula ln Q2 over Q1. Okay, so ln, okay, K2 over K1 is equals to negative EA over R. Okay, then 1 over T2, 1 over T1. Okay, our problem is to solve for T2. The T2 is in the right side, so shift this first to the left. Okay, so shift. So negative EA, not necessarily changing the sign because you are just reversing that one. Not really that transposing with signs na siya. You are just reversing that, so no need to change the sign. Okay, like this. So 1 over T2 over T1 is equals to ln K2. Now guys, you need to get the T2 man siya. Ang T2 nalambigit ba sa close and open parenthesis? Nalambigit. So you are trying to solve the T2, and then the T2 is linked to the close and open parenthesis and a certain variable EA over R. So all you have to do is to multiply it individually. Okay, so that you can have a separate T2 somewhere along the way. Okay, so mathematics times like this, individually multiply that one. Okay, so negative, algebra pa rin, no? Negative AR. Okay, then this is 1 over T2, then, okay, like this. It is positive, right? Or negative if you want. If you never change, no problem. See, negative, okay. Alam sa hilapi, okay, EA, R, 1 over T1. Okay, like this. This one. Guys, this one. Distribute. Distribution multiplication will be applicable here because it's open and closed parenthesis. Is equal to ln K2, K1. Ganon. Now, this will become negative AA, okay, R, okay, 1 over T2. Okay, like that. Okay, and this will become negative EA R 1 over T1. Mula na gyapon. Sige lang. ln K2. Buko siya kung balik. K2 over K1. This one. Actually, guys, nibalik na dyan ko. Okay, but anyhow, that's still the same. Okay, so we need to solve for the T2. All you have to do, guys, is to remove this E over R so that you can have T2. How can you do this? Okay, now. Okay, like this. So this is divide the equation with R over AA, both sides, so that you can cancel that out. Okay, here. So, asa ka mo divide, Sir Sotero? Okay, in which this particular segment or section, particular segment of equation that we need to divide, that it will be cancels out. Top, middle, or the bottom? So you have on here you have to the top, right? So this one divide by reverse R negative EA. So it's gonna be like this. So negative EA R multiply both sides, not divide, multiply both sides. Okay, yeah, multiply. R negative E per cancel siya. Multiply, sorry. Okay, because these are having denominator man siya. It's not only a solo flight variable. If a solo flight variable, then we can, cancels by divide, right? But here, this is a denominator, numerator, denominator, okay, so 1 over T2, T1 is equals to ln K2, K1. So, both sides, okay, multiply with REA. Okay, para makancel siya. So, REA. Ganon. Like this. Or negative RA. It depends. Anyway, the sense will just follow later. Okay? So just put negative REA. The science class is very easy to manage the signs compared to the variable. Okay? Like that. Okay. Like this. So if you multiply this one, look at this. If you multiply this whole thing to negative AR and then R negative AA, so this will cancel out, all right? On the left side. What will be left is 1 over T2 minus 1 over T1. Okay, ganun siya. So 1 over T2. So in this manner, you will never put close and open parentheses na siya because there's no other variables besides. The purpose of the close and open parentheses is only when having too much variables on the side. And numbers also. In here, solo flight. No need to put open close of parentheses. Okay? 1 over T2 minus 1 over T1. Now, ln K2 over K1 times, okay, negative RAA, right? Like that. So, it will now become negative R ln K2 K1A. Okay, like this. Or negative R EA ln K2 K1. Oh, nah. Okay, this one. T2. Okay, like this. Now, after that one, solve for the value of T2. So 1 over T2 is equal, transposing na kadiri. Okay, transposed. This one. 1 over T2 transposed. Right? Okay, 1 over T2. So it's equal to negative REA ln K2 over K1, and then plus 1 over T1. This guys. This one. This will be the equation. Okay? Out of this equation. This one. Out of this equation. Okay? The bottom part. Okay? Now, this equation class, this one, 1 over T2 is equal to negative REA ln K2 over K1 plus 1 over T1. It's just equal to 1 over T2 is equal to 1 over T1 minus REA ln K2 K1. We just rearrange. Okay, so 1 over T2 is equals to, okay, 1 over T1 minus REA ln K2 K1. This one. So guys, now what do you notice? We are solving for T2, right? And this is still 1 over T2. So we need to reverse. So T2 over 1. So that we can solve for T2. If you reverse this 1 over T2, when you reverse this the whole thing, the other side. Right? Because what you did in the left side, you also did do that in the right side. That's the basic in algebra. Okay, reverse. Okay, ang atong after, we need to solve for T2, and this is still 1 over T2, right? So T2 over 1, or simply T2. Okay, this one, which is final temperature now. Okay, and then we reverse this whole thing. This one, this whole thing on the right side. So we will put this as reverse. Point. So it will become 1 over T1 minus REA ln K2 over K1. Guys, this is our formula for T2. Okay, this one. So our T2 class is 1 over T1 minus R over activation energy, natural logarithm of K2 over K1. And this is our computation for the final temperature. Okay, now some books are different, but will yield the same answer. They will put T2 is equal to 1 over T1 minus RA negative EA and then T2 over Q1. Then close and open parenthesis raised to the power negative 1, which is not yet simplified for me in my part, because if you try to substitute numbers for that and raise to negative 1, it's very difficult because there's an exponential negative for that. So it's better to put that directly as 1 over the whole thing, rather than putting that 1 over T1 minus REA K2 K1 plus open parenthesis to the power negative 1, because it's also confusing having an exponent negative 1. Right? And we avoid exponent, right? So, problem. So I just put some books are putting like this. Then I reverse it with my own strategy. Okay, so that it makes us easy. Okay, like this. So 1 over T1. And anyway, the books are just emphasizing that we know that already. That's why they don't reverse finally into 1 over something. Okay, but to make it more precise, then do it now. So the students will just memorize this final thing. This one, 1 over T2, 1 over like this. So ikaw jud ang pahuna-hunahon sa libro. Okay, like this. So R EA ln K2 K1 raised to the power negative 1. Okay. This one class T2 is equals to 1 over 1 minus T1 minus R EA ln K2 K1. It's just the same as T2 is equals to, close and open parenthesis, 1 over T1 minus REA ln K2 Q1 raised to the power negative 1. Because the mean of -1 is just reversing that one by having the denominator 1 over something, right? Understand? So that's our T2 now. How can we solve for, we solve already the, the K. What is the word K? This one. K2, T2, we've done already for the K2, for the T2, and activation energy. Okay, how can we compute for the activation energy? Again, going back to the equation, specific equation that we had. I memorize na ako. So, ln K2, K1 is equals to negative EA RT. Guys, advice, before you memorize, understand very well. Okay, because it's useless if you memorize, then you don't understand what you are memorizing for. Okay, that's hint or strategy in memorizing, because it will be lost if you will never understand. That's why if you understand what you are memorizing, you can phrase your own sentence and statement because you understand what it's all about. Not necessarily the same terminologies as what is reflected in the book or what is reflected in the social media or in the Wikipedia or in the websites or whatever reference materials that you have. You can, you can restructure, you can rephrase the statements by your own if you really understand what you are memorizing for. Okay, that's a technique. Okay, so negative RT times 1 over T2 minus 1 over T1. Now, guys, we need to solve for the activation energy, right? And then we need to put this on the other side, the quantity having activation energy. Okay, because you are just only changing the position, not really changing the sign. Okay, so negative EA, okay, RT, okay, times plus and over parentheses 1 over T2 minus 1 over T1, okay, is ln K2 K1. Guys, do you notice that the technique really is, if you want to solve this particular side, you need to multiply or divide the variable that seems to be mixing so that it will become simplified. That's the technique. Okay, so that you can have the simplified one in that particular set that you are asking for. Okay, so you need to cancel that out so that bulubog siya. So that's the purpose. You need to simplify that here in the side so that you want that for your equation. Okay, that's the technique. Okay, mulubog man siya. So yung mo na siyang wag tangon para mulubog. Okay, so that's the purpose. Okay, something like that. Oh, okay, here, just like this, right? Okay, so activation energy. So distribute because activation energy man atong ipangita. Okay, so activation energy. So mulubog siya, right? So RT. Since activation energy is the one we solve, then we don't want to cancel the activation energy. Common sense, right? So we need to multiply this by RT, both sides, right? Am I correct? Okay, so RT. So multiply both sides with RT. Okay, what will happen now? RT will cancel in the left side. Okay. Okay, so cancellation method is very important in mathematics, especially in derivation. Okay, so cancel. So what will remain is negative EA 1 over T2, 1 over T1, and then RT times ln K2 over K1 is simply RT ln K2 K1. Okay, RT, okay, ln K2 K1. Okay, ganun siya. Okay, guys? Ganun siya. Then AA. So, okay. So, for the value of EA. Okay? Since we have a negative EA on the left side, divide the whole thing with negative so that you can achieve a positive activation energy. Because in the real sense of the world, there's no negative activation of energy. It's always positive because it will speed up the rate of reaction. It will never be negative unless if the activation energy purpose is to reduce the rate of the chemical reaction. But the purpose of the activation energy is to start the chemical reaction, so logically positive. Okay, in your analysis, here in your derived. So the theory will match to your derivation. It's not enough that you will keep on deriving, you will not consider the theory, right? So, because there's no negative activation energy, that's why we need to cancel this negative, right? Okay. Divide the whole thing with negative is equals to, so that we can attain and achieve an activation energy which is a positive value. Okay. So, EA. Okay. So, solve by algebra. RT. And then, guys, if negative here, positive, negative na rin siyang right side. So, negative. Okay, negative RT, LN, K2, K1. Okay, and then over 1 over T2, 1 over T1. This is the activation energy. Guys, as you can notice, this is our activation energy. Ha! So, negative RT, LN, K2 over K1. R and T are multiply with each other. Okay, like this. Okay, now class, in integral calculus, again, ln K2 over K1 is just the same with ln K2 minus K1. Okay, so rearrange again. Okay, like that. So EA is equals to negative RT ln K2 minus K1. Okay, over 1 over T2 minus 1 over T1. Okay, this is the formula of activation energy now. Okay, we've done for the 3 derivation of the activation energy is equal to negative R ln K2 minus K1 over T2 minus T1. Temperature 2 is equal to 1 over T1 minus R ln K2 over K1. Okay, but there's an activation energy for that. Okay, because there's so far T2. Negative R EA ln K2 over K1. If you try to memorize, okay, and K2 is equal to K1, E raised to the power negative A over RT. Okay, like that. So you memorize at the same time you understand what you are memorizing for. Okay, that's the purpose of the derivation of equation. Okay, that's number, in our learning outcomes class, that would be our number 5, derivation of equation here in our introduction. Okay, from 1 to 7 learning outcomes, we've done 1 to 5. And now we go to the problem solving. Number 6. This is the application from 1 to 5. Because we discussed that from 1 to 5, and then we can now have the problem solving. Okay, so we need to solve equations and formulas relating to Arhenius theory in chemical kinetics under physical chemistry. Oh my gosh, if we try to analyze physical chemistry versus chemical kinetics, physical chemistry is more broad compared to chemical kinetics because chemical kinetics is under only in the study of physical chemistry. Okay, but the parent of all is the general chemistry. So if we have the general chemistry, the under of it will be the physical chemistry, the qualitative chemistry, the quantitative chemistry. Okay, like that. What else? The physical chemistry, the clinical chemistry, organic chemistry, the environmental chemistry, right? And the earth chemistry, which is composed of liquid chemistry, solid chemistry, and gas chemistry. Okay, soil chemistry, land chemistry, and water chemistry. That's under environmental chemistry. So there's a lot of chemistry involved in that one general chemistry. Now, where is thermodynamics belong? Thermodynamics can belong either both in general chemistry and physical chemistry. Okay, but never on the other chemistry, which is the chemical kinetics, clinical chemistry, the environmental chemistry. Okay, like that. Okay, so our environmental chemistry is more on land, water, and air chemistry. We need to study the land chemistry, particularly the soil chemistry. And then we have the water chemistry or the sea chemistry. And then we have also the air chemistry or the gas chemistry, referring to the atmospheric environmental condition, something like that. Okay, it's very clear. So it's divided really. Still, we are here in the physical chemistry, and we have so many areas to cover pa talaga siya. I think it took 20 years to cover all. Charot. Okay. Nakakaloka. Okay, if we're trying to be detailed, but if you're go directly, then it can be done only 1 year, like this, whatever. Okay. So it's gonna be like that. Oh, problem solving na taha. Okay, later. Okay, because it's too long now. 40 minutes and 57, 58, 59 seconds. I think we can solve that, right? So number 6, problem solving. Oh my gosh. To save time, we don't go directly. Yeah? Okay. I have here problem number 1. This is chemical engineering board examination. 1991. November 1991. Okay. Chemical Engineering Board Examination, November 1991. Okay. The table below shows the rate constants for the rearrangement of methyl isonitride. Nakaloka. I will tell you guys, some students, if they can see a very, very amazing or, rare compound, they will be afraid. But actually, this methyl isonitride doesn't contribute into the particular problem solving here because we are not interested with the breaking down of the chemical reactions here. We are interested only with the activation energy, right? So never mind how complicated is that compound is that, right? Okay, a series of experimentation. Okay. Experiment number 1, data 1. Temperature is 189.7 Kelvin with a corresponding rate reaction constant of 2.52 times 10 to the negative 5. The unit is second negative. Now, what is this? Zero order, first order, second order. Investigate. What's the unit? Okay. So, why is that S negative only? So, it's gonna be zero order by using rate law or rate reaction constant is equals to K times initial concentration big A, like that, and raised to the power 0. When a certain concentration raised to the power 0, it is automatically equal as 1. So therefore, we conclude that rate reaction constant K is just equal to the K, or the rate of reaction R is just equal to K. Again, repeat. Rate of reaction or rate of chemical reaction, small r or the rate law, is equal to the rate reaction constant, small k, times the initial concentration, capital A, close and open parenthesis, raised to the power 0, because we assume that this is a zero order in this experiment. Now, anything raised to the power 0 is always equal to 1. So therefore, we conclude rate law or rate of chemical reaction is equal to the rate constant alone, without considering the initial concentration. That's why in our tabulation here, there's no initial concentration involved in the experiment, because this is regardless with the initial concentration for that theory and concept of zero order rate of reaction. Now, if it is not a zero order, then the table could have initial concentrations. 1, 2, 3, 4, 5. This is an analysis na siya. Okay, basta-basta mo solve, we should understand why. Okay, it's gonna be like this. Because normally, there's always concentration because it's dealing with chemical reaction, right? Because it's chemical kinetics. And you will wonder, oh, where's the initial concentrations here? You will wonder because this is a chemical kinetics. Chemical reaction must be involved here in the first place. But why it disappeared in the experimentation based on the results taken in the experiment? So you will have an idea, oh, the initial concentration was lost. So this is a zero order rate of reaction. So rate law or rate of chemical reaction is just equal to the rate reaction constant K. Ganon. Okay, now, so what is your formula of your activation energy? What is the activation energy? Is being asked. So, since we memorized already a while ago, that activation energy, we memorized, right? Negative R ln K2 minus K1 over 1 over T2 minus 1 over T1. You don't need to derive that one because it's a long story, right? Or we can have here, copy, if you cannot memorize, here, like this. But in a future examination, if you look at this, the proctor will stop you. Okay, proctor, the one who watched in the examination, and then you will fail automatically. If he or she see you copying on a certain formula there, okay, in a piece of paper, then you will automatically be failing in that examination. Okay, so all you have to do is to memorize or see that in the Paris Chemical Engineer's Handbook. But take note, it will take you a very long time to scan that, because the Paris Chemical Engineer's Handbook is very, very thick and lot of pages. Okay, it will take time for you. So to save time, memorize the activation energy formula. Again, activation energy is equal to negative R ln K2 minus K1 over 1 over T2 minus 1 over T1. Okay, now your identification is that the ln and the R will always go together. So that it will be easy for you to analyze. Okay, will always go together. Okay, just like T2, right? So T2 is equals to 1 over like that, then the R ln is there also. Okay, so the R and EA will go together. Okay, so T2 is equals to 1 over T1 minus negative EAR and K2 over K1. Diba? Nagpuyog lang yan po ng activation energy o ang R ang LN. So it's very easy na to memorize. Okay, now, for solving for K2, K2 is equal to K1 exponential. Di ba nagkuyog lang po ng activation energy ng R1T? So it's very easy na to memorize. Kaloka. Okay, so you should remember that they will go together. The EA, the R, and the LN. Then if you have to find the AA, then siya ang magbuwag dito. So what mahabilin, ang katulad ng duha. Ang anak siya. Balik ko na to. So activation energy. So ang mapabili na lang ang R1LN, di ba? So activation energy. So negative R, LN, K2 minus K1 over 1 over T2 minus 1 over T1. Because T2 and T1 magkuyog pirmi. Okay? Now, T2, okay, is equals to 1 over T1 minus, ang sa ganito yung magkuyog, activation energy over R, Ln, K2 over K1. And that's our T2. If the problem requires you to solve for T2, final temperature. Now, if the problem requires you to solve for K2 or final rate reaction constant is equal to rate reaction constant K1 times exponential raised to the power negative EA over RT. Di ba nagkuyog lang gihapon ang AA, R, and T? Ganun siya. So it's easy for you to memorize if you remember the positioning of the variables and the symbols. Okay, positioning where they are located, it's a magkuyog pirmi, and then the establishment and establishing the relationship, the inversely proportional, directly proportional, then bingo. You can easily memorize for those formulas and equations. equations, and you can put that simply in your brain cells. Okay, like that. So what is the activation energy? No, use the formula of activation energy. Okay, directly without going to the original equation. Okay, EA. Ganon. So EA solution. Okay, EA is equal to, okay, negative R ln. Then you should also remember class na ang activation energy and T2 have over effect. Na siya yung mga numerator o denominator per me. Ang K2 wala siya. So it's very easy to memorize na ang K2 involved lang siya multiplication. And then ang EA o yung T2 division siya. So na numerator, na denominator. Also, an additional K to memorize faster and easier. Okay, like that. So negative R ln, okay, K2 minus K1, okay, over 1 over T2 minus 1 T1. Actually, class, I don't plan to derive this, okay, since I found another source in which naglibog ko because negative. Okay, the other source also positive. And oh my God, what's happening for this equation? Okay, and then I tried to come to a point that I will really derive this one. I want really to dig it out so that I can understand. And then that's the time I made this. Okay, because if I will not do this, I cannot understand why it is negative, why it is positive, because other also problems presented there in my source are negative, and the other one, what's really the truth for this? Okay, and then I found out it depends on the situation. Okay. Okay. So, AA, activation energy. Guys, ang activation energy, kilojoules per mole, ha? Okay. Like this. Oh. Okay. So, Sotero, where's the R here? Hala. There's no R given. Now, if there's no R given, guys, R is always the same story with the universal gas constant used in the ideal gas law and in the real gas law in the van der Waals equation of non-ideal gas. Okay, so R will be the same. It is 8.3145 joules per mole Kelvin. Over and over again, I state this. Okay, so it's better for you to memorize. Okay, negative 8.3145, like this. Then ln, what is our K2 here? There's a lot. Experiment 1, experiment 2, experiment 3, experiment 4. Our K2 here is simply the final rate constant in our experiment results. So we need to see the last one. This is our K2. Okay? It's better to use K final, right? But anyhow, that's okay. So K2 or K final is equal to 5.36, okay, times to the negative 3. In this topic class, I don't like really because of the exponential thing. I don't like really to solve with exponential. I just try to force to solve this because, you know, there's a lot of problems like this also in the examinations. Okay, especially in the board examination. There's a lot of exponential also sometimes. Okay, so minus K1, okay, K1 2.52, okay, times 10 to the negative 5, okay, over 1 over, there will be substitution lang yun siya. Okay, T2 is equals to, the T2 here class ha is the T final, because if you try to be strict in denoting subscript, okay, we have T1, T2, T3, T4. Our T4 is this last. But it should be the T2 the same as T final, ha? Okay? So our T final or T2 is equal to 251.2. Take note, guys, this is already Kelvin. No need to add 273.15 because this is not Celsius. This is Kelvin directly. Take note in your eyes. Okay, if the unit is Celsius, oh, convert that with Kelvin. If the unit is Fahrenheit, oh, convert that with Kelvin. If the unit is Rankine, then convert that with Kelvin. Rankine is equals to 1.8 times Kelvin. So if you solve for Kelvin, R over 1.8. If in the problem solving, the temperature is expressed in Rankine or degrees Rankine. But normally that is rare. It will never show usually in Rankine. Only in ideal gas law. Okay, it will be expressed sometimes in degrees Rankine. It's equal to 1.8 times Kelvin. Okay, something like that. Okay, so 1 over T2, 251.2 minus 1 over 189.7. So our activation energy is equal to, okay, do the basic math, okay, for this, okay, direct substitution. Okay, like this. Now, calculator, please. Okay, so 0.00536 minus that is negative 3, right? Okay. Guys, if the exponent is negative, lower value, that is higher value than an exponent with negative higher value. For example, 2 raised to the power negative 5 and 2 raised to the power negative 3. The 2 raised to the power negative 3 has the higher value, reverse if exponent. Okay, if negative. Ganun siya. Okay? So it will never be negative in A minus this one. Okay? So 0.000536 minus 0.00 okay, 25, okay, 252, right? It's equals to, ganun siya. Okay, so yes. So negative 83145 ln 2.84 times 10 to the negative 3. Okay, over. Guys, do not forget the rule in algebra. What do you, the PM does. Remember that one? PM does, meaning first parenthesis, second multiplication, third division, fourth addition, last subtraction. PM does principle in algebra because it involves a lot of operations here. And then if you try to reverse that one, you start with the subtraction and addition and going on the left side, you will be wrong in your answer. This is PM does rule in algebra. Again, PM does rule in algebra. Starts with the parenthesis, okay, or bracket. Second, multiplication. Third, division. Fourth, addition. And the last will be subtraction. PM does, okay? Because sometimes in a problem solving, these 4 mathematical operations will be combined in just one setting, just like this. Okay, there's a lot of operations involve multiplication, so we need to follow the rule. Okay, you got a point? It's gonna be like that. Okay, so 1 divided by 251.2, like that. 1 divided by 251.2 is equals to 0.00398. Okay. Minus 1 divided by 1.189.7. Okay. Minus 0.005.271. At least, guys, you have to take into account or take into consideration at least maximum of 3 decimal points to consider, because sometimes you will become wrong if you will just round off immediately after 0.06 blah 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 decimal point. Okay, cover at least 3 decimal places, okay, to make sure. Okay, like that. Okay, because problems in exponential decimal places are very, very essential. Okay, dealing with 0, 0, negative, so decimal places are very important. You don't have to round off all the time. Okay, And review also the rule in algebra regarding how to round off. There's also a rule for that. Okay? So, this one. Okay? So, ln of 2.84 times 10 to the negative 3. Ayan. So, 0.00284 ln, right? ln, meaning logarithm. Okay? Logarithm of 0.0284 equals, okay, times 8.3145 equals to negative 48.76. Okay, negative 83.145 ln. Okay, negative 48. This one. So this PM gas na-apply na yun siya, guys. Nawa, guys, ha? Negative 8314 ln 2.0 negative 3, di ba? The denominator is the parentheses. We solve that first, right? Which is, okay, 0.00398. PM gas apply. Apply. Minus 0.005271. So that is negative, right? Negative 0.00001291, right? And then in the upside, okay, like this, okay, like that. So 2.84 ln. Guys, this one, take note, PM gas, okay? P, which is ahead, multiplication or division? Which is more, di ba, multiplication? So we need to do the multiplication, okay? But we need to divide first here in order we can multiply, of course, because it will be isolated. You understand the point? Like this. Okay. Times 10 to the negative 3, right? Okay, this one. Be careful, guys, ha? Be careful, because if you try to ln this one first, it will have a negative value. The negative value times negative, you will produce positive. Positive divided by negative, it will be negative, and you don't have activation energy, which is a negative value. So, wrong. Follow the PM dash. Okay? Like that. Okay, 0.00284. Okay, 0.00284. Okay. Okay. Manigative siya. Be careful dyan talaga. Okay? So, you have to ln this one the other side. Okay? You have to ln the 2.84 times 10 to negative 3 first. Okay? Divided by negative 0.00129. Okay? Like that. This one. You understand the point? Okay. So, negative. So, 0.00284 divided by 0.001291 is equals to 2.19. Okay? And then 2.19 times 8.3145. So we have 18.2 kilojoules. Now review the signs. Okay, review the signs, of course, right? So this is negative, right? So 0.001291 negative siya. Okay. Okay. ln negative 0.001291. Okay. Like that. So 18.2. Okay. Let's prove that 18.2, guys, is kilojoules per mole. The answer for this, 18.2 kilojoules per mole. This one. Now, okay, now, this is justifiable because 18.2 kilojoules is very high. If you convert that with joules, then kilo 1 times 10 to the 3, it will become times 10 to the 3, 1, 2, 3. It will become 18,200. Sorry, I will move the zeros here. 1, 2, 3. Oh, it will become 18,200 joules per mole. That would be okay. Okay, that's acceptable. Okay, now if you solve the other way around here, okay, you will not follow the PM dash. You will just divide this first, the 8.34 and 0.012. Okay. Okay. It will yield another answer. I'll tell you. 8.3145 divided by 0.001291 is equals to. See? Another value. The PM dash is very important. Sorry. Talaga. Okay, so this is 64440. Okay, positive. Okay, and then ln of 2.84 times 10 to the negative 3. Okay, like that. You divide first the number, and you did not follow the PM dash. Okay, because in here, nagsabol mong siya. We can do the either one, the either thing, you can do the division first, you can do the multiply first at the top, and then baden, divide the numerator. So a lot of things to do that. So we need a rule, the PM dash. Okay. Now this one, so 0.00284 ln, right? 0.000284 ln. Okay. Okay, ln 0.00284 is equals to negative 5.86 times 66440. See, you have a negative 3.89 times 10 to the 5 activation energy in terms of joules per mole. Okay, joules per mole, like that. Okay? So, this is not the correct answer because this is, this is negative siya, at the same time, the value is very high. Okay? So, be careful pala in solving the activation energy, like this. Okay. Now, you need to investigate, class, that in here, like this, you need to follow the sequence also. Okay? Because if you will just follow, when you break down that one, you will be confused. So, solve first right away. Even though not thinking the PM dash, right? Solve directly, like this. So, there's a parenthesis number siya. So, solve directly. So, wala siya metabo. Okay? So, 0.00284. Nakuha na itong answer, ha? We'll just prove something. Okay? ln, ganun siya. Okay? ln of 0.00284 then times 0.83.145. Ganun. Okay? So we have this negative. Okay? Then divided by 0.001291. Ganun siya. So your answer will be positive 37,765. Okay? Negative times negative is equals to positive. Positive, negative is negative. Okay? 37,765. Okay? Ganun siya. Now, there's no activation energy which is negative, ha? Sure. 101% sure. Okay? So, ganun siya. So, your answer will be 18.2 kilojoules per mole. Okay? Ganon. Really. Ganon siya. Okay, joules man siya. If you want to convert with joules, pwede rin yapon siya. Times to the 3, okay? So, kilojoules, joules, in 1,000 joules, okay, is equals to 1 kilojoules. Cancel. Siya. Divided by 1,000. So, 0.012 kilojoules for 18.2 joules. Okay na siya. Okay? The important thing is positive activation energy, and then the value is really, logical and acceptable. Okay? Like this. Activation energy. Okay? Now, let's compare that here. We cannot compare because we have still activation energy. We need to have another table to compare the activation energy if it is really increasing. Okay, because here, this is really our starting activation energy. Then we need to compute for the another activation energy just to prove that if the activation energy will reduce or not. But in here, only one activation energy, so we cannot say if the activation energy will become high, will become low, like this, right? Understand? Here we can say, because there's a lot of temperature 1, temperature 2, temperature 3, temperature 4. And then we notice that the reaction constant also is increasing. See, in our relationships, I discussed a while ago, right? This is actual experimentation. It matches to the theories and principles. Okay, that if you keep increasing the temperature, the rate constant also will increase. Look at the data from -5 exponent. Okay, and K, and it will -3, it will become high, right? Okay, then we cannot use activation energy here because we solve only one activation energy. Okay, unless there will be another, activation energy, then we can identify if the activation energy will be reduced. Let's just say that activation energy will be reduced if the temperature will be increased, okay, by the theory. Or else we can have another set of experiment like this. So we can parallel our result, that we can prove that our activation energy will really increase or decrease if we try to increase the temperature and that rate constant. But in here, it's not a good activation energy because only one setup of experimentation is here in this table. Okay, like that. Any questions so far? Like that. Any questions so far for this, But review also, because, guys, tingnan nyo, where's the formula here? Okay. Asa man to siya? Murabi siya consistent. Asa man to Asa to formula? Di ba kani siya. This T2, guys, is correct. Okay? Like this. This formula, guys, is the after or the result of integration. Right? Remember? We integrate na talaga siya. And then, if we try to reintegrate this one, this will become ln K2 minus K1, right? Then why your activation energy here is going back to be integrated again? Okay? Explain. This is your assignment. Explain. Why? Because this A is already, it's already integrated na siya. You don't have to reintegrate again. Right? Only one-time integration. And then why this activation energy formula? It's being reintegrated the ln K2 over K1. Going back to ln K2 minus K1. Why? So that is your assignment. And then if you cannot justify that one, this formula will be wrong. Okay? Like that. Okay? You understand the point? And then we can have another formula of EA again, which is negative R ln K2 over K1, 1 over K2 minus T1. But in the reference really, it's K2 minus K1. That's why I'm asking you a question. Why it's being reintegrated for the activation energy? This is not my own equation in the top. Actually, I derived already that it's gonna be EA negative RL and K2 over K1 over 1 T2 over T1. And then why it's become ln K2 minus K1 reintegrated again in the final stage. That's my point. Okay? Whereas the T2 here, it's not reintegrated. It's still ln K2 over K1 or else it will become K2 ln K2 minus K1. But why it's still ln K2 over K1? So it's not reintegrated. Right? You got the point? Because in this specific equation here, ako yung gilalis ang akong source. Okay? Kaya in here naman pod class, ako yung Jude, ako yung i-dig. This one. In this equation, guys, this is already integrated, right? This one. That's why we have the graphical like this. And then we need to solve the T2, K2, and the EE from here. So, no need to integrate again because this is already integrated. This one. Then why this activation energy in the source I obtained, okay, is being integrated back to ln K2 minus K1. It should be supposedly ln K2 over K1, the same as the T2 here. Okay, I think there's a theory behind for that, in which I don't know, right? Like this. Or another research will be done by me. Why? It's gonna be like that, right? How can I prove if I will never research again or go to another sources, right? Okay, because this is based only on my own derivation. Talaga? Here. Okay, this is your assignment, guys. Prove to me that the activation energy formula will be equal like this, negative R ln K2 minus K1 over 1 over T2 and minus 1. Then, if you can find a source, another books or whatever that could say only ln K2 over K1, then show to me and let's agree that we will use that one. But this is what I see on the other sources. Kasi, okay? But only one source, man. That's why I need your help to find another sources that could tell that this is ln K2 over K1. Because I refer only to one source for this activation energy formula. And I derive that also here. It will come out to be like this also. Okay? But I reintegrate just to meet the source I obtained. Get the point? Because if I will just stop there, I will never reach this kind of formula. My only question is why this formula is being reintegrated again in the source that I've obtained. Okay? Because I don't want to make my own, right? Just to solve this problem. Anyway, the answer is logical, right? It's 18.2, something like that. Joules. Maybe it will change now if you use the other one. Okay, like that. Research by your own, and later we'll discuss that again. Okay, why? Okay, integration, and then reintegrate again, and then final. And then if it is reintegrate again, it could have been the three quantities to be reintegrated, not only the EA. Right? Or else this T2 of mine is wrong. I still have also to integrate this. This will become 1 over 1 over T1 minus RE T2 minus T1. Right? It should be on the other way around. Okay? Like that. We already know the concept, the theories, and the principle. We are just questioning why the other one is being reintegrated and the other one is not. Okay? Maybe this is wrong, or maybe the book is wrong. The book or the source that I found out that the formula is like this. Okay? Really, because last night also, I solved, I think, 2 problems or 3 problems about this. There's also one guy presented a video that he used not a negative. And then when I keep on substituting values, the activation energy unit, and then I stop because it will become wrong. And then when I stop it, why like this? I tried to get another source also last night. Okay, after I sing, I sing a lot in my FB live streaming. I still solve problems when I reach to the other room. Okay. Okay. And I found out, oh my gosh, why like this? He used the formula ln k1 over k2, not negative. He used AA over RT, 1 over T1 minus 1 over T2. I just follow his formula, okay, with respect to his presentation of his discussion. Okay, another source, okay. When I try to solve this problem, I can have a negative answer, not the same with this answer. And that's why I stopped. Okay, I stopped because I cannot understand, right? Normally, if you can't understand, you have to stop. And then you go to another sources, of course. And then when you go to the other sources also, it's another thing, okay? There's a negative. And then it's no longer K1 over K2, but it's ln K2 over K1. And then I found out, why like this? This is not the same with the other source that I found out. And then that's the time I dig it out. Okay, I dig it out. I review some formulas in the integral calculus. That's in my introduction here, right? In my first start of discussion. Okay. Ako lahat, nag-review ko. Okay. And then I incorporate that in this topic, in this Arhenius equation. And then I found out that it is not the same with the one I looked last night. So we are not meeting with our answers. So probably, I will just say also probably, because we cannot confirm also, really, because unless I also dig it out, his formula. Okay, but I never did it. I stopped at the 8, right? Okay, so you use ln K1 over K2, and then EA over RT times 1 over T1 minus 1 over T2. And then here, basing on my research and review again, using the review of integral calculus, I obtain ln K2 over K1, negative EA over RT, 1 over T2 minus 1 over T1. Okay, now his style of discussion is he directly substitute, because the problem states what is the activation energy. He directly substitutes the values there, okay, without a separate formula of activation energy. In my case, I really get the separate formula of activation energy rather than substituting to all those values in that general equation, for the reason that I will be confused easily if I will mix that with so many variables in one equation. So I derive another activation energy formula. I derive another T2 formula. I derive another T2 formula based on the integral calculus that I've researched, the 5.1 in my introduction. So it's not the same. That's why. So that's why here in the activation energy I have, okay, here. Maybe also if I will substitute directly to the general equation here, let's try or not. If we have the same answer here, it's gonna be like that, guys. If you should have a wild imagination. Okay, so there's another option, right? Why not? So if you try to substitute that here in a general equation here and try to compute the AA here, we could still have another value that I solved here in the AA. Here. Okay, now if it is equal, then no need for your assignment. Okay, now if it is equal, no need for your assignment. Now, if the 18.2 joules I obtained is wrong and the general formula here is correct, here, now I have to adjust this formula. I will not reintegrate this again. Okay, meaning to say the reference that I obtained is wrong. You get the point? Okay, why I say wrong? Because I have the general formula here, right? Okay, and if I will substitute value and I get the activation energy, I have the value. Then I have this activation energy that I derive. I have the value of 18.2 joules. So supposedly, since I am solving the same quantity, which is the activation energy, the answer will be the same, right? Now, since this is the general equation, this is exactly the correct one because the general equation. This is the derived equation, right? Who knows, I will be wrong in here also. Okay, I obtain 18.2 joules. Now, if I can obtain the same answer when I have the derived equation from this general equation, so there's no issue. This is correct. Okay, like that. This is correct. Okay. Now, if this is wrong, this 18.2 joules I have, then I could say that this is not reintegrated. The ln part in this numerator is ln K2 over K1. I just use this one again because my source also is like this. So magkaalaman na. Okay, magkaalaman na talaga which is wrong, my source or me. Okay? Magkaalaman if I will use this general equation. Okay? Like that. Because I don't follow his, presentation because I got confused na talaga. Okay? Ganun siya. Okay? Do we have to prove that one or not? Assignment pa rin siya. Okay. Assignment pa rin siya. Okay, your first assignment will be prove to me that the activation energy upon derivation will obtain, wait, nasaan na yun? This one. This one. Okay, prove to me, like this. Okay, second assignment. If you use this general specific equation of Arhenius equation, if we substitute those values in this problem, if it is another value, okay, then we don't have to reintegrate. It's just the same. Okay, something like that. Okay, just prove. Ganun naman talaga. Okay. Oh. Okay, guys, I still have 2 problems left. What's this? Problem number 2. What's this? Calculate the rate constant at 35 degrees Celsius for the hydrolysis. Oh my gosh, of sucrose. Okay, given that's equal to 1.10 to the negative 3 square meter, second negative, not meter. See, this is molarity or molar at 37 degrees Celsius. The activation energy is 185 kilojoules per mole. Wow, baliktad. Okay. Take note, guys, the rate constant has different unit in the first example. Okay, here. So it's gonna be first order, second order, or third order. It depends on your analysis, Basta imo lang yung hinumduman, I'll show you. Okay. Puro nakalimot ko. Basta, sa general chemistry, wait, I will recall first, Okay. Wait, give me 5 seconds. Ay, nako. Okay, A plus B. Okay. Ganda siya. Okay. In zero law, so I remember that. Okay, A is equals to B. Like this. Ganun. A reactant is equals to B product. Ganun siya. And then, lawi. Lisod lagi siya. Okay, rate constant is equals to K. Rate low is equals to K times the initial concentration of A, right? This one. And since there's no number of moles beside the A, this is 0, right? So this is 1. So rate constant is just equals to the rate low. Okay, this one. R is equals to K. And then, since you know, guys, that the rate is having a unit of seconds in the denominator, that's why, class, our unit of K here is also negative S to the negative 1. That's the reason behind Why the unit of the rate constant is equals to second negative 1? Because of this principle that R is just equals to K. Okay? Why is negative? Because the time per second is always in the denominator if we talk about the rate. Okay? So it will be justified. Okay. Negative 1. Now for the first order, what can we do for this? Anak ko, nakakaloka. Okay. So let's try to have, let's try to have 2 moles of A, right? 2 moles of A is equals rate. Yes. 2 moles of A. A is meaning to say, guys, is a reactant, any kind of chemicals, ha? A is just hypothetical, just to purpose of discussion lang yun siya. So 2 moles of concentration A will produce into B. Where's the A here? Okay, this one produce into 2. So let's say B2. Okay, B2. Nakakaloka. 2A is equals to B2. Just to balance the number of moles, man. Balance siya, o 2, ganun lang siya, o. Okay, alam sa rin yung seryoso, ha? More sa rin siya, okay? Okay, rate low is equal to, wait for a while, ha? Wait. Okay, rate low is equals to K concentration of A raised to the power 2, right? This one. Okay, reactant man siya per me, guys. Okay, so that's why your K unit here is, okay, molarity second negative 1. Anong na molarity second man? Okay, let's check. Okay. Okay. Your A, guys, is concentration, and that's molar. Okay, let's substitute. Okay. So, bising lang din sa akong nahinumduman sa chemistry. Okay, so K, okay. K, A substitute the molarity, molar. So, molar raised to the power 2. Okay. And then R is equal to, ano siya, 1/2. So, K molar, the spot kayo niya siya, ha? Times 2, kulbaan magani ko. Okay, so ang K na to, guys, is, it's solved for the value of K, magod siya. So, K is equals to, oh my goodness, M to the 2, okay? And then R, which is 1/S, second, okay? So K is equals to 1/S, okay, value is R, and then M raised to the power 2. Hala. So it will become, kung ano siya, 1/S M2. So, ano siya, eh? Okay, wait. Algebra! Okay. So, kung 1/S, ganun siya, no? 1/S. So, this is just the same as M2. So, all you have to do is M2/1 man na siya, diba? So, it will become 1/M2. So, K is equals to 1/S times, oh my goodness, this is 1/M2. Okay, 1/M2. So this is K is equals to 1/M2 S. Chararat. And then K is equals to 1/M2 S negative. Then 2. Let's ganon. Okay. Kapit na lang yun, guys. Okay, at the spot magod siya. So, our unit for K here is M2 to S negative 1. Let's review because my unit here is 1/M2 S negative 1. Kapit na lang yun siya. Nabaylo na siya. Okay, review. Okay, so 2A is equals to B2 as our let's say second order reaction. So R is equals to Ka raised to the 2. So R is equals to Km2. Let's solve for the value of K. So K, again, nag-review ako ha. K is equal, just to prove na unit na to sa K is M2, it will become second order. Okay, so K is equals to, okay, K is equal to R over M2. Okay, M2. Then K is equals to, the unit of R is equal to 1 over S negative, because that is the rate. Okay, so 1 over S negative. Di 1S lang siya, 1 over S. Ibutan mo sa baba, may mo siyang S negative. Okay, so 1 over S, and then M2. Okay. Alaoy. And then K is equals to E. Negative lang nato siya para hindi na siya bulubog. So S negative. Okay, over M2. Then K is equals to if it is M2 over 1, so it times nito siya. So M2, K is equals to S negative 1 is understood to be M2 over 1. Right? So S negative 1 over 1, so this will be 1 M2. So M2 S negative 1. M2 S negative 1. Okay. M2 S negative 1. Siya. Bilang mo yung M2 S negative 1. O, sakto siya. So this is M2 S negative 1. The unit, this is a second order pala siya. Okay? Sure ba? Oh, yes. Talaga. Second order rate of reaction. Okay? Ganun? Yes. Second order. This one. Second order rate of reaction siya, guys, ha? Number 2 problem. So, dependent siya sa, concentration. Really. Okay? Like that. Of all the rate of all the order of reaction, only the zero order is independent to the initial concentration. Okay? Remember that always, ha? Only the zero order is regardless with the initial concentration. That's why in a problem, wala huge high initial concentration is present in that particular problem because it is independent with the initial concentration. That's the purpose there. But if there's a presentation or there's a data of concentration in your experimentation, then you have the concentration like that. Okay, but it depends also if it will just ask activation energy, because the formula of activation energy, it doesn't require the concentration man put siya, regardless of K. Okay? Regardless sa ano siya, di ba? Formula dra, formula una din ay concentration reari man. Okay? Puros naman ay K2, K1, ganun siya. Okay? So, you don't have to worry if the activation energy is being asked. Something like that. The problem is if you're going to ask with the relation of the concentration. That's a problem. Okay, for example, K is equal to R, rate of chemical reaction is equal to Ka raised to the power 2. Now, you solve already the value of K through this general equation. Okay, here. Okay, so if the question will say, what is the concentration? So you need to solve the concentration through that second order formula of rate law. Understand? Kung naman sa kay K, yun naman sa kay A. So, ang makuha niyo mo siya. Okay? So, how can you do that? So, apply the initial rate method of concentration. You remember that one? Initial rate. Determining of initial rate method. 1 by 1. 1, 2, 3, 4. Ganun siya. Okay, and then 1 to 2, then substitution of 1 to 3, and then apply the integrated law of the rate of reaction. Because you have also the formula of the first order, second order, and the integrated law. Okay, the other one is the basic not integrated O, but the other would have the integrated O. So remember that one? And there's also the equivalent half-life and ganon. Half-life value. Why? Because this is dependent with time. Because it is rate. Okay, rate low. There's a time. Okay? That's why in the unit always have seconds. See? Seconds. It will never disappear. The second in the unit, in the rate constant, will never disappear because chemical rate reaction is dependent on time. Okay, dependent on time. Even though that is a zero order. But for the concentration, the zero order, di mo siya dependent sa concentration. But the time is dependent all throughout. Zero order, first order, second order, third order. Because sometimes also in the examination, it will be like this. What particular quantity is dependent in all order rate of reaction? A, temperature, B, time, C, pressure, D, volume, E, activation energy, F, concentration. Munganga. Okay, munganga rin ka, kaya waka ba sa theory. Okay? So all you have to do is to analyze that the temperature dependent yun siya ang rate law o ang rate of chemical reaction. So in that simple question, maglibog na ka. Okay? Because you don't know that the chemical rate of reaction is dependent all throughout with time because rate involves time in the denominator. Okay? And at the same time, you can never be determined how fast or slow the chemical reaction rate is if you will never consider the period it takes to be fast, to be low. Something like that. Okay, so time dependent. Okay, like that. Sometimes it will confuse in the theory examinations also. Okay, now if the activation energy will decrease, what will happen to the time? A, B, C, D, E. Apply this theory and then use this equation. Like this, and then use the inversely proportional, directly proportional, and so on. Use also the definitions. So what is the definitions of Arhenius? Go back there. Okay, then you can find the relationship also. But the problem also, guys, in my introduction, it is general. It is not really stated that if we increase the temperature, we will increase also the rate constant. Because the definition of the Arhenius equation is like this. It describes the relationship and the relation between the rate reaction constant and the temperature. Okay? What kind of relationship is that? It doesn't mention if it is directly, inversely, if it's reduced, right? You will analyze in the formula, right? Of all physical and chemical reactions. So that is Arhenius equation. Okay? So you could not depend for the definition of Arhenius equation. So all you have to do is to depend for the equation. Here. The original. Where is that? Hindi na ko makita. Ako na memorize. So K is equal to A E exponential to negative E RT. Now, you cannot depend also to this equation. Why? Because there's an exponent. You cannot relate the proportionality through an exponent. And remember, the temperature is in the exponent. How can you relate if it is inverse or directly? It's very difficult to do that. So you need to find another formula so that it's very easy to determine the relationship. Okay, in my derivation here, I have the 3. So find here that is more easy to analyze. Okay, here. Okay, here. Let's say activation energy is here. Okay, negative EA is equal to negative RT ln K2 minus K1 over T2 over T1T. This is only good for the relationship between the temperature and the activation energy and the temperature, like that. Okay, it's still okay, K2 and K1, but there's an ln. Okay, so that's one. So activation energy is directly proportional to the R and to the T. It's okay, right? And EA is inversely proportional to. No, it's not also, because it's still 1 over T. It's the reverse. It's not only the T. Okay, so you cannot use this also. Another. Let's review. Okay, this one. Kakano, grabe kayo, okay? So, temperature. Atong gi-prove, guys, ang relationship. Okay? Like that, okay, so this one. This is not also because T2 is directly proportional to the number 1, which is a constant and never holds true. And this is difficult also. Okay, K2 is the last yung atong may K2, K1. Okay, K2, K1. Okay, K2, K1. K2, K1. This one. Ako lang memorize yung kinawa ko. So K2 is equals to K1 times exponential. Lagi pa exponential. So in this class, you can never use the equation to determine your proportionality relationship. It's very difficult because this is integrated. So the only way to do that is to have the memorization. Okay, memorization of the concept. Okay, like that. So if you increase the temperature, you will increase also your rate reaction constant, and you increase also your rate of chemical reaction, then your activation energy will become low. The one I discussed in the first topic, right? And then if you add catalyst, you increase also your chemical rate of reaction, rate constant, like that, and you lower also your activation energy. If you increase your concentration, there will be no effect of the rate constant, but your reaction, chemical reaction rate will increase. And then also, the activation energy will go down. So this is the only way we can have the analysis of our relationship where it will go high, it will go down, it will decrease, it will increase. Because in the future examinations, it could not be denied that there is like this type of question. Okay, so if you don't memorize these aspects, then you will get lost. Because you cannot relay the formula. Because the formula is equals N, and there's a lot of like this, unless it is an algebraic formula, just like density is equals to mass over volume. Impulse, force over time. Momentum, mass times velocity. Acceleration, velocity over time. Speed, distance over time. Force, like that. Force, mass times acceleration due to gravity. Okay? In terms of gravitational pull of energy to the earth. And then force is equals to mass times acceleration in terms of horizontal motion and movement of a car. Like this. It's not the same with gravity, right? Because gravity, force is equals to mass times acceleration due to gravity. Something like it's different. Second law of Newton in physics. Isaac Newton, second law of motion. Okay, so in that manner, it's very easy to determine the relationship because that's only algebraic expression without involvement of integrated formula. Okay, now you can clearly see the difference. Okay, like that. So that is only for the theory questions. But if the problem solving, no problem. Go ahead because it's only analyze and use the formula. But I mean the theory and concepts. Okay, like that. Because in future examination, 60% up is the theory. Okay, the problem is just only few. Really. Okay, so it's not really that offers a big percentage in the examination. It's only like 30%, 40%, like this, like that. Okay? And if you will only get 75% up out of that, then you will pass. Okay? Because they will just inject 20% difficult problem solving. So you have at least 80. Of that 80, be sure you should at least have 75 up. Then you will pass. And that composed of theories, something like that. Okay? And then if you get lost for the theories, then okay? You will fail. Something like that. Okay? So be careful. Something like that. So be careful for both problem solving and theories, concepts, and principles. But in my part talaga, what made me pass is the theories, concepts, and principles. Okay? It's not the problem solving. Really. Okay? In my case. Okay? That's it. Because I'm not doing mathematics as I told you over and over again. Okay? So like that. So just build adequate memorization. Okay, and understand what you memorized. Kana lang siya, okay na. Solve na talaga siya. Because equations and problems, you can also memorize. Okay? And then you can also memorize the way how it is being solved. And then if it will repeat again, then do that again in the same manner. Then bingo. Okay? Unless they will give a problem that you never solve that in your entire life for the very, very first time, then you will be wrong. Okay, that's the time you have a wild imagination, you have critical thinking of your analysis. But most of the times, 70% up, you really encountered that before. The only thing is there's an additional chupa-chuchu. Okay, additional chupa-chuchu meaning they try to link another quantities, not on that specific topic. For example, this is unit operation. And there's somewhere thermodynamics inserted in that particular problem. And there's also chemistry in that particular problem. There's also physics in that particular problem in which maglibog na jud ka because ihansak tanan on that particular problem in only one paragraph. So that's only the tendency, what makes it difficult. Okay? That's very clear. Okay, but if you try to connect the dots, you can have your own formula. Okay, like you can have your own formula after collecting all those kind of formulas. For example, for the top, okay, activation energy o ganon. Activation energy. Di ba na siya pwede ma-apply sa kuan kay Albert Einstein? Theory of relativity of Einstein. Energy is equals to the speed of light raised to the power 2 times the mass of an object. Can we treat liquid or solution as an object? It can be, right? Because when we speak of object, it can be solid, it can be liquid, it can be a gas. Object is a general term referring to 3 types of phases of matter. So we can, it's possible, we can equate mc squared to this activation energy here. Here. Okay, so we can now have, this is wild imagination. Okay, if you want to become an engineer, you should have a wild imagination. So activation energy is equal to mc squared is equal to negative r ln k2 k1 over 1 over e2. It's possible, right? We don't know. Okay, like that. If the problem will mix the speed of light somewhere along the way. For example, here, calculate the rate constant of the 35 degrees for the hydrolysis of sucrose, and sucrose will pass through the light through spectrophotometer like this. And the value of the light is 3 times 10 to the 8 to 7 meters per second. And then the K constant is at 7 degrees Celsius. The activation energy is the mass of sucrose. Oh, there's a mass. Okay. And then libog na kaya speed of light. And then this equation here doesn't involve speed of light. What you will do? Since you know there's a theory of Albert Einstein that E is equal to mc squared is equal also to energy, it equate that here. Okay? Like that. And then you can solve for the activation of energy. So this is the case makes it difficult. Okay? Because we are not used to solving this kind of problem. But it's possible due to the possibility of the theory that the energy is equal to the mass times the speed of light raised to the power 2 is equal to the activation of energy in a chemical reaction to this sucrose. We modify the problem, huh? We modify the problem and then we apply this one. So we can solve. Things like that you have to, okay? Looking out for the possibilities, because I experienced that also in day 3 in the chemical engineering. I used another formula in which I never met in my entire life. Really. I just connect all like that. Then I'm tired. What's gonna do for this? And I keep on repeating. That's very difficult. That was the last problem I solved in chemical engineering. Okay, and I really found out another problem. When I solve that and I get the answer, still it's not in the choices, but it's near to the choices, and I choose that one. I don't know if it's correct or not because you will not return the answer sheet. Okay, and then when I look at my seatmate, all are coming out in the examination room. And I'm only the one left in that examination room. And then Engineer Amis Pakamalan, our head of chemical engineering department, she was there because she always cheered us up during chemical engineering examination. She's very supportive to us every time, and she visited there in the examination after. And then she said to me, "So tira mo medyo giti-iti." Ako medyo kono giti-iti. Kung mapulisod mo gud pistanan, nung ako kabaw kong buhaton, mo to nigawas ko. Nakitaan mo ko yung ako ra jud ang nahabilin sa examination room. Okay, and if you believe it or not, my chemical engineering was the highest score in my results. Okay, the second is my physical and chemical engineering, and the third is my mathematics and general engineering. Because as I told you earlier, I'm not good in mathematics, right? So it really proves on your performance after the examination. It's gonna be like that. Okay, so my point there is don't be afraid. If you don't encounter that before, just try all kinds of equations and formulas that stacks in your brain cells, then bingo, use it, utilize it, something like that. Okay, so that's it for all chemical engineering students that will be able to take up chemical engineering board examination this coming October 2021. So that's gonna be a technique, something like that. Okay, thank you so much for listening to this. Oh my gosh, long time period of live streaming. It reaches to 1 hour and 55 minutes with these topics. Okay, ano ba ito ako mga topics? Our learning outcomes. Okay, for this live streaming. Guys, I need to have a long live streaming sometimes because it will give me a little bit higher than you if you really watch that one. Okay, live one. Okay, this one. Okay. Dami ko mga papel-papel, guys. Okay. Next time, I'll try to improve my live streaming and vlogging through having a whiteboard chart. And then, mobile phones tend to, to capture video. Okay. Like that. Sana ba to? Like that. Oh my gosh. Boring kayo, no? Okay, I found it boring, but I found also enjoyable. Okay, this one. Okay, this is our learning outcomes. Principles and concepts, done. Formulas, done. Quantities, relationships, done. Graphs, done. Derivation equation, done. Problem solving, done. Others, chuba, chuchu, chika, chika, done. So these are all about Arhenius Theory of chemical kinetics under physical chemistry. Thank you so much, guys, for watching this long live streaming. If you think you learned a little bit of this discussion, then you can comment down below in the comment section. And if you are not subscribing yet my YT channel, then you can subscribe now if you want to. Okay, and then you can click the notification bell for some news updates. So I am a singer, eternal voice, Sotero. Bye bye, guys, everybody. See you later.